So, good morning. Today we'll be discussing about the signal generators. Topic named signal generators. So, it is a vital component in a test setup and in the electronic troubleshooting and development, whether on a service bench or in a research research laboratories. So, here this which is being considered as a vital component in the test setup and in the electronic troubleshooting and development area, and it which has a variety of applications, whether it will be utilized for checking the strain gain and frequency response and alignment of the receivers. They provide variety of waveforms for testing electronic circuits, which usually at the very low powers. And next one is the oscillator, which generates a signal, that is sinusoidal signal, from a DC source at some specific frequency. And next one is the generator, which provides several output waveforms like sine wave, square wave, triangular wave, pulse trains, and AM waves, etc. And the signal generators, which has what kind of a requirements it has. The signal generators has the frequency of the signal, which has to be known, and it has to be very stable. The amplitude should be controllable from very small to relatively large values. The signal should be distortion free. See, the signal should be always distortion free. The above requirement may vary for special generators such as function generators, pulse generators, and sweep generators. So the requirements which we have already said, like the frequency of the signal should be known and stable. The amplitude should be controllable from very small to relatively large values. The signal should be distortion free. It may be varied for the function generators, pulse, and the sweep generators. And it has a various kinds of signals, like signals at AF and RF instrumentation system. And the oscillator, it has a fixed frequency form, which is like excitation of AC bridges, variable frequency form in case of Q meter for covering of the wide range of the frequencies. And the frequency band limits, like we have listed the bands here, and what is the approximate range of the frequency band limits. One is the, so AF is 20 Hz to 20 kilohertz, and RF is above 30 kilohertz, and VLF, that is very low frequency, is from 15 to 100 kilohertz, and low frequency LF is from 100 to 500 kilohertz, and broadcast, which is from 0.5 to 1.5 megahertz, and video from, that is DC 5 megahertz, HF 1.5 to 30 megahertz, VHF, that is 30 to 300 megahertz, UHF, that is 300 to 3000 megahertz, and the microwave, which is behind 3000 megahertz to 3 gigahertz. So these are the frequency band limits, where we listed the number of bands like AF, RF, very low frequency, broadcast, video, and HF, VHF, UHF, and the microwave sections. And the approximation ranges for from AF, like 20 Hz to 20 kilohertz, to microwave to, which is behind 3000 megahertz to the 3 gigahertz. And then when coming to the fixed frequency of the AF oscillator, which has a it is represented as the self-contained oscillator, which is used to generate a signal at some specific audio frequencies. So for audio testing, it has a 400 Hz to 1000 Hz for exciting bridge circuiting. The oscillations at the audio frequencies are generated by the ion core transformer to obtain positive feedback through inductive coupling between 1 degree and then to the 2 degree windings. So you just see here, the oscillation at the audio frequencies are generated by audio core transformer, which is to obtain the positive feedback through which the inductive coupling between 1 degree to the 2 degree of its winding. And the variable oscillations, variable AF oscillators, which ranges from 20 Hz to 20 kilohertz, which we already seen in the ranges and the bands on the ranges. So 20 Hz to 20 kilohertz, which has the full range of for the laboratory performance. So it has the full range on its laboratory purposes. And then the pure sinusoidal wave or of the output over the entire frequency range it acquires. And the RC feedback oscillator or the beat frequency oscillator is being used here. And the basic standard signal generator, this is what the basic sine wave generator, that is the where we set the frequency, set the level of the attenuation, and then towards the RF output. So the sine wave generator represents large signal category of the signal generator, and the frequency range of this from few hertz to several gigahertz. And we have not mentioned any value for the basic sine wave generator frequency range, because it may be from the few hertz to the several gigahertz, and it consists of the two blocks. So one is from the oscillator and another one is the attenuator. So it consists of the two blocks. The first block is the oscillator and the second block is the attenuator. So when coming to the performance of the generator, which depends on the success of this oscillator and the attenuator, the accuracy of the frequency, stability and freedom from distortion depends on the design of the oscillator, and amplitudes depends the amplitude which depends on the design of the attenuator. You just see again, the performance of the generator depends on the success of these oscillators and the attenuators. The accuracy of the frequency and the stability and the freedom from the distortion depends on the design of the oscillators, and the amplitude depends on the design of the attenuator. And the next one is the standard signal generator, where it consists of the RF oscillator, where it finds with the range on the frequency wide to the wideband amplifier to the output attenuator. From modulation frequency to the percentage of the modulation, you go with a modulation oscillator, and the external oscillation is being connected through the modulation oscillator to the wideband amplifier and then towards the output level. So in the where the standard signal generator, it produces the known and the controllable values. So it voltages, the voltage is known actually, and then it is being controlled, which is it is being used as the power source for the measurement of gain, BW, SWR and the SNR and the other things, and it is extensively which is being used in the testing of the radio receivers and the transmitters. It provides the modulation of the carrier frequency, which is indicated by the dial setting front panel. So the modulation of the carrier frequency, which is indicated by the dial setting of the front panel. The modulation is indicated by a meter, and the output signal can be AM or FM. Either it might be AM or it might be FM. So the modulation can be done by a sine wave or a square wave, and a triangular wave or a pulse wave. So it can be done, the modulation can be done either with a sine, square, triangular or a pulse waves. And then the carrier frequency generation, which has a stable RF oscillator with the LC tank circuit, which has a constant of the output power over any frequency ranges. The frequency of oscillations is indicated by the frequency range control and the vernier dial settings. So the frequency of oscillations is being controlled or indicated or evaluated by the frequency range control and the vernier dial settings. And the AM is provided by internal sine wave generator or from the external source. The frequency stability, it is limited by the LC tank circuit design of the master oscillator. And coming to the range switching, which is accomplished by selecting the appropriate capacitors. Any change in the frequency which upsets the circuit design, and the instrument takes time to stabilize to new resonant frequency. Now you just see clearly, when the range switching accomplished by selecting appropriate capacitors, there is a change in the frequency which upsets the circuit design, and then it needs to take the instrument to stabilize to new resonant frequency. In high frequency oscillators, the buffer amplifier, where the isolation from the output circuit to the oscillator circuit. And then to the modern signal generators, you have a RF oscillator, frequency divider, automatic control towards the motor, auto and the manual conditions is there, and the power amplifier assembly is there, frequency divider is there, amplification of the amplifier from 1 to 9 setups of the frequency divider is being done here. On the audio oscillator, 400 Hz is there. So when come to the modern signal oscillator, it improves the stability first, and then the signal master oscillator is designed for highest frequency range, and the frequency dividers are switched to produce the low ranges. The master oscillator is made insensitive to temperature variations and influence of the succeeding stages by careful circuit designing. So the circuit has to be designed carefully to master the oscillator, which is made with the incentive to temperature variations and influence of the succeeding stages. Then the temperature compensation devices are used for any changes in the temperatures. The frequency, which is ranges for the modern signal generators, which is from 34 megahertz to the 80 megahertz. And coming to the buffer amplifier, the isolation between the master oscillation and the power amplifier, which eliminates the frequency distortions. And the ranging, which switching between the effects is also eliminated, since the same oscillators which is being used in the all the bands. See, the range switching effects has been eliminated because it has the same oscillations, same oscillator which is being used in the all bands. The master oscillator is tuned by a motor driven variable capacitor, and the coarse turning slides the main frequency at the approximately 7% frequency changes per second. The master oscillator has both automatic on the manual controllers. That is what we have seen in this diagram. Both auto and the manual sectors is there in this conditioning. Then the internal calibration is provided by the 1 megahertz crystal oscillator. The modulation is done at the power amplification stage. For this, two internally generated signals like 400 Hz and 1 kilohertz which is being used. The modulation is done at the power amplification stage. The modulation is done at the power amplification stage, this stage, power amplification stage, and then it is being used with the 400 Hz and then 1 kilohertz is being used. And the modulation level, which is adjusted up to 95% by a control device. Flip-flops are also used here for the used as the frequency dividers to get a ratio of 2:1 ratio. And then AF oscillator. So in this AF oscillator, you have Wien bridge oscillator towards amplitude, and you have a square wave sharpening, amplifier square wave, attenuator to the square output, and then sine wave amplifier to the attenuator where it gets a sine output. So that is what the AF sine and a square wave generator diagram representation does. So when come to the explanation of that particular thing, so the AF signal generator is called as an oscillator first. So and Wien bridge oscillator, which is used this generator because it is best for the audio frequency. See here, the Wien bridge oscillator is being used here for just for the best for the audio frequency ranges. And the frequency of an oscillation can be changed by varying the capacitor and also in steps by switching in resistance of the different values. The output of the oscillator goes to the function switch, which directly to sine wave of the amplifier or the square wave sharper. At the output, we get either sine wave or the square wave. You just see, or the output we get either sine wave output or the square wave output. And then it generates the frequency range from 10 Hz to 1 megahertz, which is variable in 5 decades. And a sine wave of 5 millivolts to 5 volts, that is RMS, and the square wave of 0 to 20 volts peak to 30 to 70% of the symmetry, it is being utilized here. And which is required 7 watts power at 220 watts to 50 megahertz, it is being used. And the front panel of the signal generator, which is consist of frequency selector, frequency multiplier, amplitude multiplier, variable amplitude, symmetry control, amplitude, function switch, output available, sync, and the on-off switch. When coming to the frequency selector, it selects the frequency in the different ranges and varies continuously in a ratio of 1:11. The scale is non-linear. So it has a ratio of 1:11 and the scale is non-linear. Coming to the frequency multiplier, it selects the frequency range over 5 decades from 10 Hz to the 1 megahertz. And coming to the amplitude multiplier, it attenuates the sine wave in 3 decades and which is with into 1, into 0.1 and into 0.01. And variable amplitude, in coming to the variable amplitude, it attenuates the sine wave amplitude continuously. And coming to the symmetry control, it varies the symmetry of the square wave from 30% to the 70%. And amplitude, it attenuates the square wave output continuously. Function switch, it selects either sine wave or the square wave output. Output available, this provides sine wave or square wave output. And the syncing is this terminal which is used to provide synchronization of the internal signal with an external signal, and the switch on off switch is been alternatively it is been used. So this is about these signal generators. So we have gone through in this class about the signal generators, basic signal generators, frequency band limits, and then what is the standard signal generator and its explanation, and its model signal generator and its explanation. So thank you.